Greetings everyone and happy spring. It's hard to believe that the school year is already coming to a close and that this is our last Math Fix task together. I hope you've enjoyed these monthly challenges as much as I have and that they've satisfied your cravings for a simple yet challenging problem. So without further ado, let's jump into our last task. Today's Math Fix is brought to you by F-LE.A.1, which asks students to distinguish between situations which can be modeled with linear functions and with exponential functions. Let's take a look at our problem today. Students are asked to help Carolina and Christian, who have started a cookie business, to decide between two different structures for paying commission to their employees. Carolina thinks they should pay a commission of $2 per box sold, while Christian proposes a structure in which the commission doubles for each additional box sold, starting with 2 cents for one box, 4 cents for 2 boxes, and so on. Which commission would you recommend? Let's find out. At this point in the school year, students might start by organizing their thinking into a table to compare the two commission structures. One misconception, however, might be to forget about units. This would lead to a table where it appears that the two commission structures are the same, when in fact they are very different. Students should soon realize that Carolina's plan is in dollars while Christian's is in cents. Adjusting for this, they can see that for 0, 1, or 2 boxes, Christian's plan seems like a great option. They would only have to pay their employees 4 cents if they sold 2 boxes, where with Carolina's plan they would have to pay $4. At this point, students might conclude that Christian's plan is the one to choose. They may even extend the table out a bit further, say up to 5 or 6 boxes, to prove their point. And if the typical employee would sell around this many boxes of cookies, they would be right on to recommend going with Christian's plan. But what happens as employees sell more and more boxes of cookies? Students will want to find out if there is a point where Carolina's plan becomes more desirable. There are many ways students can go about this. One way is to simply keep extending the table. In this case, they do not have to go that far to find out that at 12 boxes of cookies sold, the commission paid with Christian's plan is much greater than that paid with Carolina's, $40.96 compared to $24. Kind of unbelievable, given that it starts out with just 2 cents. Some other ways they might go about this are to use graphs or equations. Graphing the two on the same axes confirms that by the time an employee sells 12 boxes of cookies, Christian's plan will offer them a much greater commission, and in fact, continuing the graph reveals the distinct difference between the two plans. Carolina's being a straight line or linear relationship, and Christian's being a curved, and in this case, exponential relationship that grows extremely quickly after about 12 boxes are sold. One extension could be for students to represent each of these plans symbolically with equations. To do this, they might go back to the table and notice that Carolina's plan is increasing at a constant rate with a slope of 2 and a y-intercept of 0, so the equation is y equals 2x. To find the equation for Christian's plan, one way to go about finding an equation might be to simplify things a bit in order to discover the rule. They might think about the original instance where they created a table with no units. Here, Christian's plan simply involves multiplying by 2 for each additional box of cookies sold, so 2 to the x. However, realizing that this is in cents and not dollars, they could then divide this by 100 for a rule of 2 to the x over 100. Another way they might find an equation for Christian's plan might be to, instead of simplifying, complicate things a bit in order to discover the rule. They might notice that each time they are multiplying by 2 one more time. So, to generalize the pattern for, say, 10 boxes, they would have multiplied 0.02 by 2 a total of 9 times. For x boxes, then, they would need to multiply 0.02 by 2 x minus 1 times, or y equals 0.02 times 2 to the x minus 1. A final extension, then, could be to use these two equations to find the point of intersection. For this, they might need some more advanced math, or to use their graphing calculator. This is beyond the scope of this Math Fix, so we'll leave that for you to explore. And that's this month's Math Fix task, folks. We are so pleased that you've hung in there with us this school year, taking on each month's challenge like a pro. Have a wonderful rest of your school year. Until we meet again.